on public-private partnerships on expanding the reach of ITS. I'm going to give you kind of an overview of what we've been doing with the fiber optics within UDOT and what we've been doing with several of the telecommunication partners to expand the system and what we do with it. I'm Lynn Yoakum. I'm with UDOT and I manage all of the fiber optics statewide in each of the regions. This is Brian Christensen. He's with Horrocks. He manages a group that we've contracted with him by RFQ to help us do all the mapping and a lot of the support of the fiber optic system, and he's also an ITS engineer designer. And so he's got a lot of experience with what we're doing. We trade with a lot of partners. About every telecommunication company within the state we've probably got an agreement with, or we trade, or they're within our systems. If you've done design on any project, one of your calls is going to be who's in the trench with you when you're coming across a section. Is anybody in with you? Who else do we have to work with on any of the replacements? We also work with a lot of the state agencies that are out there. We've got UTA, where we work with a lot of the preemption and everything. We also have UCAN, UEN, AGRC, who does a lot of the mapping, and Division of Technology Services. At some of the areas within the regions, all of our region buildings connect together back to a single location. And at the Traffic Operations Center, so you've got Region 4, you've got St. George, you've got Region 1, all of them home run to one single location at the Traffic Operations Center. And a lot of that carry comes across our partners that we work with. So that's something that we're kind of proud of, because we have point-to-point private connectivity. It doesn't go out on the internet, which helps with a lot of the security issues that we have. A big key to doing and developing public-private partnerships is planning. Planning is key. Working with your regions, working with a single point of contact for the state. A lot of the states that go to develop trying to do public-private partnerships without having a one-person point of contact to be able to ask for the trades and what they're doing makes it really difficult to keep consistency within the program. And we found that we have a section we call the Fiber Group. Hey, Leon. And we work as a single point of contact for the state, for the regions to call up and work with, for the telecommunication companies to work with, and we help coordinate with other states on best practices to try to help them do and emulate a lot of what we're doing. Also, understanding what our telecommunications wish list is. We meet with them and ask them, do you want to be in this portion here? We provide a fiber map that's out there. If you Google UDOT fiber map and take the first hit, it's on a Horrocks Esri box for us. That shows you our extensive fiber optic network throughout the state. And it's pretty impressive when you compare it against a lot of the other states that are out there. Know what facilities are available within the right-of-way. We do a lot of coordination. Right now we're trying to coordinate across 123rd South, and we're going to be looking at populating with microduct on the trade, and that's what we're going to show you a little bit later on that we've got over here to show you how we can expand some of the systems for the trades with some of the newer technology. Coordination with right-of-way is extremely key, and just getting information out to them. If you look at this chart, it shows you over the last about 7-8 years, well, actually from 2001, this is where we were starting to prep the system for the Olympics. And you can see at the end of 2014 where we're at. We have about just under 1,000 miles of UDOT-owned system, and you can see the light blue that goes up. That's over 1,000 miles of shared system with other telecommunication companies. If you look at the diamonds as they grow up, that's the trade value that we've traded with each of the companies that we track on a spreadsheet to say here's what we feel the value is and what both of us agree that the value is at. And so that gives you a good overview. We're now going to move into Big and Little Cottonwood Canyon. This is one of our public-private partnerships, was to get those canyons built so that we could put ATMS devices up there. And avalanche, we're just finishing connecting the avalanche sheds, the chain-up signs, sensors, anything to try to help make the canyon safer. We also partnered not just for safety, we partnered for economic development. Big and Little Cottonwood Canyon, if you had been up there a few years ago, not a lot of great signal. In fact, about 7 miles in Big Cottonwood Canyon was total dead space. No radio signal, no cell phone signal as you came out. And to be able to get high-speed internet with these public-private partnerships up there helps out tourism for everybody that's on the slopes, when you're hiking, for safety if you have an accident, and for conventions that they can attract up there. Who doesn't like to go to a convention? Have you liked your Wi-Fi here? Could you imagine going up to a conference and that was so slow that you couldn't, like kind of what last year was here? Yeah. So I'm going to turn the time now over to Brian to tell you about the Big and Little Cottonwood Canyon Partnership.
Thanks, Lynn. A couple of things we missed on the housekeeping. Just passed around a sign-in sheet, so if you want credit for attending, get that. And I think there's also certificates up here that we'll hang out afterwards and sign those if you guys need CEU credits for other states. Anyway, so yeah, I'm going to get into some specific examples of what we went through for P3 project in Big and Little Cottonwood Canyons. Started the process about 4 years ago and finished construction, well, last summer, but it's still not fully complete yet. Just wanted to talk about some of those challenges that we faced and aspects of the project. So Big and Little Cottonwood Canyons, obviously just east of here. You guys are all pretty familiar with it, I'm sure. Big Cottonwood is in red. Little Cottonwood's in green, home to 4 major ski resorts, and because of that, that generates a lot of traffic. We get a lot of snowfall, and very popular for winter and summer recreation, skiing, biking, hiking, and that type of thing. So it's a very popular place. But as the second bullet shows, they get average of over 500 inches of snowfall every year, and so because of that, it creates a lot of challenges. This photo is on the morning of a powder day, and this is what I dream of every morning during the winter, is like, okay, it's going to snow and I'm going to go up and tear it up. So but you can see the long line of cars waiting to get up there. At this time, typically the avalanche crews will close the canyon and do avalanche control work, doing their blasts and such. And then the people at the bottom wait to go up and take advantage of the new snow. But sometimes if an avalanche does come down, this is what will happen. You'll get a huge deposit of snow that will cross the road, and so because of that, the department's been trying to control when and how these avalanches get released. And they've been doing a lot of different innovations over the last several years, putting in new devices and new technologies up there. But the challenge has been, well, let me show you. This is Little Cottonwood Canyon, showing the different slide paths that are there. There's over 30 active slide paths within Little Cottonwood Canyon, and the road comes right through here. So you can see a lot of those slide paths will cross the roadway. So it creates a huge challenge for trying to balance the users of the canyon versus the weather events. Coupled with that, there's a huge communication, as Lynn mentioned, a huge communication, lack of communication, I'll put it that way, within the canyon itself, because there's been no hardline communication up the canyon itself. And so emergency response folks, your avalanche control people, ski patrol, and your general everyday users haven't had a reliable means of communications besides just two-way radios. A few years ago, the Little Cottonwood specifically is fed via microwave radio, or has been fed via microwave radio, and that is fed through a station over here in Riverton. And a few years ago, that line to that feed was cut here in the valley for some road construction. and that canyon went completely dark for 8 hours. They had no communications in or out. So it was a huge challenge, because you've got ski resorts that are trying to accommodate their guests, and you've got hotels and lodges that they can't make phone calls and that type of thing. So the system was severely overwhelmed. And then all the operators also had a challenge trying to manage everything. So 4 years ago, Crown Castle Communications, they approached UDOT and said, hey, we want to build a project in Little Cottonwood Canyon and Big Cottonwood Canyon, and this is how we propose to do it. We're a wireless infrastructure company, so we build these wireless cell phone networks, and we lease the bandwidth off to all the major carriers. So we'll come in, we'll build our infrastructure, and then everybody that comes into this system can have their cell phone, whether it's on AT&T, Verizon, T-Mobile, or Sprint, and then everybody can have access to that system, but there's only one system that's going to be built, rather than having a set of antennas for Verizon and so on and so forth. It works great in a canyon environment because of it's obviously it's a challenging terrain and that type of thing. So UDOT agreed to the idea. They liked the approach because they've been wanting to have communications up there for a long time. The way these systems are built is through fiber optics. That's kind of the main backbone that connects everything and makes everything talk. So what they proposed that they would do is they would build the fiber optic backbone within the road right-of-way, and build the antenna poles also within the UDOT right-of-way, and they wanted to have access to the UDOT conduit that was already in the canyon. I'll show you where that conduit existed already in a minute. And they also wanted to build a hub space, which is kind of the central brains of the system within the canyons as well. So this is a map of Big Cottonwood Canyon. The existing conduit that UDOT installed with the shoulder widening project is shown in yellow. It's about 5 miles long, and they did it as part of a, like I said, shoulder widening project a few years ago. But it didn't connect to anything. They didn't have anything put into the conduit. It was just there. And then Crown was going to install the blue portion. And then Little Cottonwood Canyon, similar type of thing, where another shoulder widening project for a different project is in the yellow, and then Crown proposed to build the blue portion, and then to link the two canyons together, take advantage of existing UDOT conduit on Wasatch Boulevard. So as part of this trade, UDOT was going to receive some strands on the fiber cable that this company was going to install. They were going to have a spare conduit, and they were also going to have access to all the poles that would be installed next to the right-of-way for cameras and such other equipment, as well as some RWIS equipment. And UDOT is going to receive free power for all their devices, and space inside the hub for UDOT's fiber optic equipment. So we started the NEPA process. Big and Little Cottonwood Canyons are scenic byways, so that presents a whole different set of challenges. Just the stakeholders and the agencies involved. I mean, this is just a snapshot of a few of those who we worked with. The biggest one being the Forest Service. They're the federal jurisdictional agency over both canyons. Technically, they actually own everything underneath the road. UDOT owns the road itself, but anything that has to do outside of roadway operations has to go through the Forest Service. So the NEPA process was a Forest Service NEPA document. But then we had to deal with these other agencies as well. And then there's other stakeholders that had also oversight and input in addition to that, plus the private ski resorts. And so counting it all up, there's over 20 different stakeholders that we tried to build consensus with to say, yes, this is a good thing. Yes, we're going to be able to protect the canyons and make this happen. So it took a long time. It took about 2 years to get through the NEPA process and get everybody bought off on the idea and supportive of it. So then we went to design. This is a schematic drawing of the poles that went in. You can see the upper portion of the poles have the antennas behind a canister shroud at the top, but there's space on the pole for cameras and some other radar equipment, and then a control box down at the bottom. These are for the radios that provide the cell phone service. So as part of the design, while we're flying, we had a lot of challenges that had to deal with the granite rock. Obviously, we had some creek crossings as well. There's no available power in the canyons, and a lot of existing utilities, aqueducts and stuff, and it was a very constrained right-of-way. And then everything we were building was going to be inside of the road right-of-way inside the clear zone. So a lot of things we had to take into consideration as we went through the design. Then during construction, that introduced a whole different set of challenges as far as involving the stakeholders and this significant amount of limitations we had to put on the contractor, because the canyons are, it's a watershed area, right? So anything that we had to protect the creek, that was like in both creeks, that was the utmost importance, because that water flows down into the valley and we all drink that water when we turn on our faucets every day. And so significant amount of oversight had to be put into place over the contractor to make sure that they were taking precautionary measures. For instance, they couldn't open up any more trench than 500 feet a day, or excuse me, at a time, before they had to backfill it, because of just the risk of exposure of polluting the creek. Traffic control was an issue, and night work noise, and a lot of environmental controls. We did have significant challenges with some environmental groups. I won't get into any specifics, but it was interesting. And then in addition to that, we had to be out of the canyons on the weekends because of the recreational users that would be up there to go up. We built the two projects in the summers of 2013 and 14. And so on the weekends, a lot of hikers and mountain bikers and users of the canyons had to be in the canyons, or were going up, so we had to be out of there by Fridays at noon. So the way our contractor built the project is with a rock saw. I mean, that's really the only way to do it. You can't bore it, you can't trench it, it's much too rocky. So this is kind of this is a photo of one of the saws that was used in Big Cottonwood Canyon, which wasn't as challenging because it's a little more open. In Little Cottonwood Canyon, we had to use something a little bigger. The diameter of that's to scale. That's that saw blade is about 8 feet in diameter, and it can tear through just about anything. And it's not running at this time in this photo when I took it, just so you know. When the trench was opened up, placed the conduit inside and backfilled with the concrete, backfill rather than a flow fill, just because of our depth. We went with the shallower depth because of the amount of granite rock that was in that are in both canyons. I want to show this video. I don't know if we're going to get audio with it or not. If I plug this in. Oh yeah. So let me show this here. Oops. Anyway, that's kind of what it looked like. It was pretty cool to watch that. This is a close-up shot of the trench itself, and you can see that those are granite boulders inside of there that the saw just cut a nice clean line through. It's pretty impressive. We had 0 blowouts when we trenched this thing in there because of the size of that saw. And here's another kind of a side action view of what that looked like. So you can see the boulders all through there. It did a really, really impressive job. Some more construction photos. This is one of the foundation for the poles that we put in with the spread footing and going around a corner, and then we did some bridge work as well. When we crossed the creeks, attached everything to the existing bridges that were there, and then we stood up the poles. This is a photo of the hub in Big Cottonwood Canyon that was set as a precast building. There's actually another one that was set right after one. This one was for Verizon, and then AT&T came on shortly after, and theirs is right next to this one in Big Cottonwood. And this is the picture of the final product of one of the poles in Big Cottonwood Canyon with the antennas at the top, a CCTV camera down below, and a cabinet. As part of the system, what we ended up doing is designing 7200 volt medium voltage systems to power everything in mini circuits. And so because there's not really power at for the full length of the canyon. There's a few meet points where we could pick it up, and then we just ran our own power. And so at all the poles we had transformers to step it down and that type of thing. So just an overview of the project. The total cost to the Crown Castle was over $5 million. With that, they got 35 poles and about 25 miles of fiber optic conduit and cable and some electrical systems. UDOT got 12 new cameras, 8 RWISs, and 15 electronic chain-up signs that they could now control remotely. And UDOT's total cost in this was very, very minor. Again, as Lynn mentioned, this public-private partnership, I mean, UDOT really had to spend virtually $0. I mean, it was just, well, it was maybe $100,000 in equipment or something. 350? Okay. Okay, so it wasn't quite zero. But it was less than a tenth of the total project cost. And again, it's because of these partnerships that she's so adept at doing. So some more of the benefits, obviously, is that now people that use the canyons can use their cell phones, including the ski resorts. The avalanche control shed is also connected to the DTS network, and the ski resorts and everything else can all take selfies when you're going down the slopes and stuff. But as part of it, though, the cool thing is that it's expandable, right? I mean, everything in fiber optics, you have an unlimited amount of data. Well, maybe not unlimited, but you've got a lot of data bandwidth that you can play with and add more devices on later. And so this summer, UDOT brought the electronic signs on board so they can turn on and off the four-wheel drive and the change required flashing signs and that. So it was a good project, and I think a good showcase of what these partnerships can bring. So for the next 15 minutes or so, I'd like to just go over some of the new standards that we've been developing for the department in helping these trades out. That has to do with microduct and microfiber. As we've been going through these projects, we've been noticing that we open up a big wide trench, put in 4 tiny conduits about this big, and then we backfill it and put a T-patch over it, and it's pretty obtrusive, and it takes a lot of manpower. And so we talked to some suppliers, and they showed us this microduct and microfiber technology, which is a lot less obtrusive. And we've got some examples that we'll pass around. But basically, there's 2 different types that we're going to be using going forward. And these don't replace the existing standards that UDOT already has in place. These are more just another tool in the toolbox or another set of equipment that are allowed. The example on the left is a bundled, and that's what this is. This is a 7-way bundle, and we'll pass these around to you guys so you can take a look at them. So the bundled microducts come in different types and sizes and different configurations. As part of the standard, you'll see this on the next release of the standards. We're allowing for a 2, 3, or a 4, or a 7 bundled microduct. And those are well, you can see the size is 16, 13 millimeter, and that size can accommodate up to a 288 strand microfiber cable, because it's a different type of a cable, and I'll get to the cables in a minute. And the great thing about this technology is that this conduit can be installed with the typical installation practices, only it doesn't, I mean, bored, trenched, plowed, that type of thing. It doesn't take any really specialty equipment to install the conduit itself. But again, it does allow for greater flexibility and less impact onto the roadway, and faster cleanup, faster restoration. And in addition to that, well, I'll get to that in a second. The next piece is individual microducts. So the black one that has 4 on it, they're kind of different size, but the one that's black that's got 4 in it, those are the individual microducts, and those are meant to be installed wherever we have existing 1 1/4 or 2-inch conduits. Those can accommodate up to 144 strand cable. And those conduits you can fit 4 or 5 of those inside of a standard 2-inch conduit. And so this allows more I guess, pathways for the DOT as well as for future telcos to come through and trade for that. So the example on the right that you see is how we've typically been installing our conduit and cable. You know, a decent sized conduit with a small piece of fiber cable in it. The example on the left is more of a micro technology. You get a lot more pathways for the same outer sheath, and this is an example of typically of what the cable looks like inside of that bundle. Going to the installation. So because these conduits are a lot smaller, we can go with a lot smaller trench width. This is just a small rock saw, and you can see they're installing individual microducts in this trench, and so it's a lot less obtrusive for everything. And then for restoration, there are couplers available for those as well. And then the cable itself, I want to show you kind of the difference of what the cables are. Maybe you want to do that. I don't. So the cable on the top, if you can look at the thing, that's our standard, has been the standard 72 strand cable. And the cable on the bottom is the standard, is a 72 strand microfiber cable. So you can see it's quite a bit different, a lot smaller. Anyway, so it just kind of gives you a feel for what that looks like. But there was no way you could fit a standard 72 strand loose tube buffer cable inside of a regular microfiber conduit, a microduct conduit. It's got to be the smaller. So we're decreasing the size of our real estate, but still keeping the same capacity from a fiber perspective.
And if you look, you can see that fibers are actually the same. Is that the gentleman?
Yeah, so she's showing that the fiber strands themselves are the same size. Obviously, it's just the outer sheathing and the buffer tubes have gotten significantly smaller for this technology. So the one challenge with the microcable though is it's not armored, and so that presents a different set of challenges by itself, but primarily being that we can't locate on the cable itself like we typically have been able to do if it's been an armored cable. And so the microduct has got a locate wire that has to be installed along with it so that we can locate it. One of the other benefits on the microfiber cable is that it is, because it's smaller, contractors can bend it a lot. It's got a smaller bend radius limit on it, so it's easier to install. And then everything, when they install the cable, it's all air blown through a jet, and so you don't have, there's no pulling or anything like that, and they can get about 500 feet a minute when they blow it through there. So it goes a lot faster. Contractors that we've talked to, and maybe Bob, you can talk to this a little bit more, but their success on being able to install this has been faster. And so
How did 36 go, Bob? You spent a lot of time out there.
Yeah, well, you know, and actually, in some cases, we have shorter runs. Beehive out there, they opted to make one short run between 1,000 and 1,100 north just by pushing the fiber through, and it went right through their duct. So it was easy then. We haven't really gotten to a point yet where we're going to blow fiber, but when we do, we'll be able to shoot long distances through the entire system. So, but the whole process, like you mentioned earlier, we opted to do most of the work trenching right now. The trench is built to old standards, even though we're using the new microduct. So it sort of lays in the bottom of this large trench now, but it's to get the depth and to make it longitudinally straight and everything is a lot better. It's not as subject to bend as much, so you can get the minor curves for your vertical and lateral type movement or bend, and it just doesn't exist as much in this new microduct. So it's going in really fast, and over what I've seen in the past. And now even I guess we're doing at 201, we're actually doing a 3 duct system, which would be a blue, an orange, and then 1.25 inch orange, which I'm going to go out and look at later. But but that's the system is this microduct is really the way I see a lot of longer runs like along the freeways and where we don't have as much laterals, because there it becomes a hazard and or a problem with having to break it every time we have to go into a junction box.
If you noticed on the, thanks Bob, if you noticed on the samples that we passed out, the interior of the microducts are ribbed, and that allows for the cable to just ride on top of those ribs, and that's why they can blow it in at such a high rate of speed. So in addition to being less obtrusive or on the construction, the contractors are telling us that they spend less time installing the product. And so the other benefit by using this technology is that we feel that that we'll see construction prices go down, and we'll start saving more money on our projects and be able to put that money elsewhere by not sacrificing anything from a capacity standpoint. In fact, like I said before, the number of pathways we're getting is actually greater. Before, we would do a traditional 1D, which is 4.25 inch conduits in a bundle, so that would give us 4 pathways. Well, for the same price of materials, we're getting a 7-way bundle, just in materials alone, not counting the fact that we're going to spend less money on installation costs. And so because of that, we're able to get almost twice the number of conduits, or pathways, I should say, and then the other benefits of reduced construction cost. So it's still pretty new. As Bob mentioned, we've done it on 2 projects right now. There's a 3rd one that's coming out to bid here in about a month, and we're just kind of evaluating to see how it goes. I don't feel like the 1D or the 2D are going to go away completely. We think that they still have their place, but you know, we're excited for this because, well, actually, the department did a project 10 years ago in St. George on Bluff Street, where they put this in, and it went really smoothly because it was a really tight area and they didn't have any right-of-way, and they couldn't trench it, and boring was next to impossible. But they went in and it's been working fine. And so we're trying to make it a little more mainstream. So those are the benefits to it. It is a little bit more temperamental. You have to be a little more careful because we don't have the big buffers and stuff that we used to. And so the guys that handle the cable have got to be a little more careful when they cut it open to do the connectors and things. But it's overall, though, we've seen that the contractors, they're used to it because they work with it in the telco industry, and the telcos don't mind it because they're already using it for their stuff. So we think it's been a win-win overall. So I think that's the end of our formal presentation. Yes.
So what's the long term? I mean, I can see this being a concern next time we go back to retrofit the road, right? We go back and we do a mill and fill, and we end up wiping out 5 miles of fiber that wasn't a cost previously because it would have been down below. What's the design standard? What's the new thought on that?
We haven't talked about changing the depth requirement at all. These examples that I showed earlier were just more of an example of, hey, we can get by with a really narrow trench width. So the depth requirements, we're not talking about changing those. We're still going to keep it 3 feet, 5 feet. And, you know, like I showed earlier in the Cottonwoods, that was really shallow because of the terrain. And we've done that in other places, like on Black Ridge and stuff. But we're not planning to change those depth requirements at this time.
So we're not going to be seeing projects come out where we're able to just saw cut down the middle of the road?
No.
That's too bad.
Well, I never say never, right? I mean, it's still
well, Mike,
happen.
we're looking at Logan, which you know, right? We were looking, and instead of going middle, if we come more over to shoulder side and take it down.
Right, that would be a situation like the Cottonwoods. I was just curious. One of the graphics you had there looked like it was just a small saw cut. And I was just curious if that was where the department was going, where we would just be saw cutting and dropping in those 2 and 3
It's not, it's something to think about because you can still get the depth if your saw blade is going down. And so when they come through with mill and fill, it would be the same depth as your, yeah, if you go down to depth. Yes, you need to sweep to the sides. You got to sweep to the sides. When we talk about sweeping to the sides, you've got to have the boxes. When we access the boxes, that's what Leon's talking about. If we don't sweep to the sides, you've got to close a whole lane, and it's a pain. So when you do design with any fiber optic system, and if we're having to go on the road, we have to make sure we have pull-outs where we can have a truck, we can have access to be able to open up the lids and bring out the splice points. Very key. So that's good.
Smaller boxes, pull boxes?
You technically could have smaller pull boxes because the coil of the fiber is much smaller. You could, but the splice cases are still about the same.
They're the same size.
So your type 3s would have to stay the same.
But like I said earlier, it does have a smaller bend radius, and so you don't have a huge coil of cable inside. For the same 100-foot cable, you can get by with a lot smaller coil inside the box. So the boxes are going to get cleaner too, especially if you have multiple cables coming inside.
And Leon, just for you, it's not armored. It's not armored.
Any other questions on any of the stuff that we've talked about? We're going to end a little bit early. Well, we've got, I think we go till 11:50, but any questions on any of the project stuff or on the microfiber or microduct? Nope. Yes, Brad. Yes, yes. It'll come out with the next version of the standards. We just got word last week that they've been approved. We're going to create some new bid items right now. So we're not going to change the standard drawing. Right now, it's just going to be special provisions on what's going to be allowed. We think the specs can be written around enough to show what's, to give the contractors enough intent of what we're trying to get. So we don't think a drawing is going to give us any more benefit. But right now, so we're developing, there's going to be new pay items for MD7, which is the 7-way bundle, MD4, that type of thing, or individual microducts. And these will also be reflected on the UDOT fiber map as well. We're tracking those separately on a separate layer. So if you guys know what that is, when you pull that up, you'll see that as a new line style on those.
Is groundwater a concern? For the conduits, are those conduits completely encased in concrete, or is it just poured on top?
Are you talking about in the cottonwoods? Yeah. Really wasn't a concern. I mean, we're pretty high above. It was just mostly the rock that we were trying to avoid, and yeah, we didn't have any infiltration of water inside the conduits from the concrete backfill. It was fine. It's pretty standard. We typically just backfill it with a flow fill in an open trench, but we elected to go with something a little harder in this case because we're only going 18 inches deep, so we wanted to protect it. Yes, Bob.
The one thing we're doing in SR36 is rather than flow fill, we're using sand mix, and we're making sure that there's a buffer under and over the conduit, and it goes in faster, and later on when you have to go back in and repair it, there's less chance of damaging that conduit in a sand mix than that old flow fill was.
Yes, we like the sand. So do the contractors. They didn't like putting in flow fill.
Yep, exactly. Anything else from anybody? We'll let you guys get out of here early for lunch then. Thanks.
Thank you, guys.